Hello, this is Mrs. Raro, and I am here to teach you how to use your inverse trigonometric ratios. Okay, so in this video, I'm going to show you how to find the angle in a triangle using two sides. All right, so far you have used sine, cosine, and tangent so you can find the missing side. But this time we're going to be given two sides and we're going to find the missing angle. All right, we can use this using inverse sine, inverse cosine, and inverse tangent. All right. So again, this is as a reminder, there's SOHCAHTOA that you need to remember. So in theory, if you're given the opposite side and you're given the hypotenuse side, you can find the angle using inverse sine. That would be the same thing for inverse cosine and inverse tangent as well. So if you know the adjacent side and the hypotenuse side, you can like reverse it so you can find the angle. Okay. All right, so before we begin, you always have to make sure that your calculator is in the correct mode. So if you enter tangent 45, so let me go here, let's do tangent 45. And then if it equals 1, then that is correct. But right now, my calculator is not in the correct mode. It equals 1.6. So that means I go right here, and I'm going to highlight degree. And I'm going to do it again, tangent 45. That should equal 1. So now I know it's in the correct mode. So if you ever go to any scientific calculators, you should have this symbol right here. Above sine is sine -1 to the power of -1. This is read as inverse sine, inverse cosine, and inverse tangent. And then again, they can be found in the same buttons, sine, cosine, and tangent. You just have to press shift. So if you have a calculator like mine, you have to press shift or second and then press sine, and that should give you the inverse sine function. Okay, so here if you have a calculator, you just have to look for the shift button, unless you just shift. Here, inverse, it's the inverse right here. Okay, so if you click inverse sine, you should see it. All right. Okay, so now let's begin. So first, let's test to see how this is used. So let's say find inverse sine of 0.8. All right, so you just do inverse sine, arc sine of 0.8, and then close the parentheses. So that is the degree measurement that they're talking about, right? So 53.13 would be the angle that makes this ratio of 0.8, okay? All right. So let's do another one. Inverse tangent of 2.3. So inverse tangent of 2.3, close parentheses, and 66.5 is the angle degree measurement that they're referring to. Okay. There's another one, cosine, inverse cosine of 0.45. So inverse cosine of 0.45. All right, again, this is another angle measurement, so 63.26 degrees is the angle measurement they are referring to. All right, so that is practicing the calculator and how to enter it in. And now let's actually try to find the angle measurement. So let's say A is the angle that we're looking for, or angle of interest, right? So we put a star here. This is what we want. The two sides that are given to us is this 9, which is AB, and this 15, all right, which is AC. So the first thing that you have to do is identify and label the two sides that are given to us. Okay, so the first thing I always do is look for the hypotenuse. So that roots out making the mistake of labeling adjacent, right? So this is the hypotenuse because it's across from the 90-degree angle. And then the next thing is I look for the name of this, the name of this side. So 9 is considered your adjacent side because it's next to the angle A, right? BC, if this was given to you, then this would be your opposite side. So right now I'm going to ask myself which one of these sine, cosine, SOHCAHTOA are we going to use given you have an adjacent and hypotenuse? And the correct answer here is Ka. Okay, so now we're going to use the cosine ratio and set it up like how we always do. Cosine of A, since you don't know the angle, cosine of A is equal to adjacent side over hypotenuse, so 9 over 15. Okay, so now to reverse this, we're going to take the inverse cosine of 9 over 15 and we will get angle A. Okay, so if you go to your calculator, you go to inverse cosine, and in the parentheses you put 9, which is the adjacent side, divided by 15, which is the hypotenuse, and then you should get 53.13, just like what they got, 53.13 degrees. Okay, so once you have this angle 53.13, and if they're ever asking for angle C, you can also use either a different trigonometric ratio, or you can use the third angles theorem, because you know this is 90, this is 53.13, and you can subtract from 180 to get angle C. Okay? All right, let's do some more examples. So let's say this is the angle, right, that they're looking for. This is a starred angle. So let's look for the hypotenuse first. So 13 is your hypotenuse, all right? And then this angle right here, we call this angle theta. So that's how it is pronounced, theta, all right? And then so across from theta is 12, so which means 12 is your opposite, all right? So I'm going to use SOHCAHTOA, and then I'm going to see identify which one I should use. Opposite and hypotenuse is so I'm going to use a sign. Okay, inverse sign. So we're going to do inverse sign, and or if you want, I can take it step by step. So sine of theta is equal to opposite over hypotenuse. The opposite side is green, so that's 12. And the hypotenuse is 13. All right, so now when I enter this in the calculator, I'm going to enter it in as inverse sine of 12 over 13. And then I'm going to get my angle. Okay, so let's go back to the calculator, and we're going to do inverse sine of 12 over 13. And now I should get my angle, 67.38. So 67.38 is your answer. Okay, so fairly easy, I hope. Let's try another one. All right, so again, I'm going to try to look for the hypotenuse. So this is the hypotenuse, right? So if there is nothing there, I don't need to worry. I do that again because I want to make sure that I'm not mislabeling the hypotenuse with the adjacent side. So now this is a starred angle, which is angle D, right? Across from angle D here is the opposite side. So 23 is the opposite. And then next to it is the adjacent side, which is 13. So now SOHCAHTOA. All right, so which one am I going to use? Looks like I'm going to use TOA, right? Opposite over adjacent. So I'm going to set up a tangent ratio. So tangent of angle D is equal to the opposite side over adjacent. So opposite side there is 23, which is red, and the adjacent side there is green, so that's 13. So now when I enter it in the calculator, I should do inverse tangent of 23 over 13, and then I should get the angle. Okay. All right, so let's go to the calculator, and we'll do inverse tangent of 23. Oops, sorry. To do inverse tangent of 23 over 13. And then press enter. So our angle that makes angle D is 60.52. So 60.52 degrees. So that means this one is 60.52 degrees, which would make it easier for you. Also, find angle F. All right? So I want you to try this out. Okay, so this is different. They're different measurements. So try this out and see if you get the answer to angle F. Okay, so we can figure out angle F because we're given this is your hypotenuse, right? And then this is your adjacent side. Okay, then we label SOHCAHTOA, and it seems like we're going to be using cosine. So we set up a cosine ratio of cosine F is equal to adjacent over hypotenuse. So the adjacent side there is 27, and then the hypotenuse there is 35. Okay, so now we reverse it by taking the inverse of 27 over 30, 27, the numerator. So 27 over 35, and we should get our angle measurement. All right, so let's go here. And so we take the inverse cosine of 27 over 35, and then we get 39.52 degrees. So this angle F is 39.52 degrees. So angle F is 39.52 degrees. Okay, and that is it. Thank you so much for watching this video. Bye-bye.